All right, guys, welcome to the second slash third-ish day of the periodic table. I'm going to see how much I can get through this without losing my voice, so let's begin. My first question to you is, what is a trend, right? If you guys keep up with social media, you've seen the broom challenge trend that's going on social media, Twitter, Instagram, all that jazz, right? And all a trend is, it's a general direction in which something is developing or changing, right? We see social media trends. We see fashion trends, right? It's something that is changing, developing over a direction, right? And so that's what we're going to be looking at today. All right. You can pause the video as you copy down the objectives, right? But today you're going to be able to compare atomic radii of different elements and contrast the trend as it proceeds across the periodic table and down the groups. You're going to be able to explain the trends and patterns of ionic radii compared to neutral atoms. And you're going to be able to compare ionization energy and electronegativity and explain how these properties change across and down your periodic table. All right, so this seems like a lot of words and a lot of things to know, but we're going to get through it. All right. So periodic trends, the definition that I want you guys to copy down is that it's a pattern on the periodic table that describe changes in chemical properties of the element. Okay. And we're going to look at three periodic trends today. We're going to look at atomic radii or radius, okay, ionization energy, and electronegativity. So let's get started on our first one of atomic radius. Okay. Atomic radius is just the size of an atom, meaning I'm going to measure it from the nucleus all the way to your valence electrons. And valence electrons, we're going to learn this in the next lesson, okay, are your outermost electrons. Okay, so if you see over here, I have a nucleus. Valence electrons are those ones that are going to be the furthest away, okay? And my trend, okay, for atomic radius is as I move down my periodic table, I'm going to have more electrons, right? Which means that additional energy levels, which we're going to look at also tomorrow, makes my atomic radius increase or get bigger. Okay, so as I move down, my atom gets bigger in size. Okay, but as I move across, okay, more electrons are actually going to be attracted, okay, to the nucleus, making my nucleus hold on to those electrons, and my atomic radius actually gets smaller. Okay, they're going to be more compact. Okay. So here you have a diagram of those energy levels, right? And we said that as you move down, they get bigger, right? So if I see hydrogen, I have one electron, right? So I'm only going to have that first energy level. It's pretty small, okay? Lithium here has 3, so I'm going to have one energy level that's going to hold 2, and then I'm going to have a second energy level. So I have a second ring compared to hydrogen. If I look at sodium, I have that first ring, I have that second ring, but now I have a third ring, okay? And it's going to continue on, so my next one would have 4 rings, next one would have 5 rings, so on and so forth. So it gets bigger as I go down, all right? As I go across, though, they get smaller because I'm able to hold my electrons closer to my nucleus, okay? So my biggest elements down here, okay, on this periodic table, it's cesium. On your periodic table, it's francium, Fr. Right, that one right here is going to be my biggest element. And my smallest element is helium, okay? So what I want you guys to do right now is the periodic table that is in your reference table. I want you to draw these arrows just how they are. Across the top arrow, I want you to write decreasing, meaning that atomic radii is decreasing. And along the one that goes down, I want you to write increasing, meaning that it gets bigger. And make sure you specify that it's atomic radius, okay? So maybe I should have written this here saying atomic radius decreasing, okay? Same thing, add atomic radius here. So pause your video and do that now. All right, so we are back. And so before we move on to the next 2 trends, I want to do some practice, okay? So I want you to order your atoms from smallest to largest, meaning from the smallest atomic radii and then increasing to your biggest. Okay, so pause your video right now and do set 1 and set 2 in your notes, putting it in order from the smallest element to the largest element in terms of atomic radii. All right, so atomic radius can also have an impact on ions. Okay, we have learned that a cation is a positive charge, okay, meaning that they lose electrons, right? So if I am losing electrons, that means that I am going to be losing an electron from that outer ring. And so I'm actually going to have a smaller ionic radii if I compare it to that neutral atom, right? So if we looked at sodium, right? If sodium lost an electron, okay, sodium is actually going to have a smaller ionic radii. Okay, sodium ion is going to have a smaller radii than it is if I was a neutral sodium atom. And the reasoning why is my positively charged nucleus can better pull in remaining electrons and hold them closer to the center, making it smaller, right? So once I lose that electron, I can compress my atom. If we know that that's the trend for cation, anions, okay, are pretty much the opposite, right? They have a negative charge, they gain electrons, and so my anions are actually going to have a larger ionic radii, okay, because I cannot hold that many electrons in, and so they're going to move away and spread out, okay? So my oxygen atom, right, if I lost my 2 electrons, okay, my oxygen ion, right, my 2 minus, or not lost electrons, I gained electrons, my bad. Okay, let's start that over. Oxygen, when it gains electrons, it forms a 2 minus charge, okay? So oxygen 2 minus is going to be larger than regular neutral oxygen, okay? And in true Miss Round fashion, let's talk about cats in this way, right? Imagine you had a nucleus. Okay, maybe it's a cat toy. All right, so your cat toy is your nucleus, and your cats are your electrons. And I'm proposing to you guys, is it easier or harder to herd all of the cats if I had more, right? If you guys have cats or have ever experienced cats or even dogs in this matter, right? I know that if I'm a cat ion, I have lost electrons, so I have fewer cats. Okay, it is easier to herd those cats around the cat toy and my radius shrinks. If I'm an anion, it means I gained electrons, which means I have more kitty cats, right? And so it's harder to herd them all around the cat toy, right? So my radius is going to grow. What I want you guys to do now is I want you to pick the atom or the ion with the largest radius, okay? So this is in your packet. You can, or not your packet, your note page. You can pause the video and you can do set 1 through 4 and then come back when you are done. All right, we have a couple more slides. So we just talked about atomic radius. We've talked about ionic radius, and now we're going to shift gears. All right. The next trend that we're going to talk about is ionization energy. And the definition for ionization energy, it's the energy that's required to remove an electron from a neutral atom. Okay, so how easy is it to lose electrons? Okay. We already know that if I have a smaller atomic radius, it's closer to the nucleus, right? So I'm actually going to go all the way up to this side here, right? I see that this electron here is super close to the nucleus. Okay, my outermost electron is super close to the nucleus. But if I look at sodium, right, my outermost electron is a lot farther away. Okay. So in terms of ionization energy, it's looking at, okay, this guy here is holding my nucleus, or holding my electron close to my nucleus. This guy's not, okay? So if I move down my periodic table, my atomic radii gets larger, okay? which means my ionization energy is smaller. So it's going to decrease because it takes less energy to remove that outermost electron. Okay. As I move across, though, right, we know my periodic trend is my atomic radius gets smaller, so it's holding it closer and closer to that nucleus. I'm going to increase my ionization energy, meaning that I'm going to need more energy to remove that electron because it's so closely held together. Okay. And my general trend for ionization energy is helium and my other noble gases, so my group 18, are actually going to have the highest ionization energy. And we have a lovely, like, topographical periodic table on this side here, right? And I see that as I go across, right, my ionization energy increases, okay? As I go down, they get smaller, right? So let's look at group 18, for example, right? My highest is helium. As I go down, my columns get smaller and smaller and smaller, meaning I need less energy, right? As I go across my periods, it gets higher and higher and higher and higher, meaning I need more energy. So what I want you guys to do, and I'm going to make some edits here right now, okay? What I want you guys to do is pause the video, and I want you to do the same thing that you guys did with your atomic radius. And I want you to draw arrows, and I want you to tell me that as I go across, ionization energy increases, and it decreases on the way down. So pause that, do that right now. All right, so we see that, right, my noble gases have the highest ionization energy, with helium being the top. So if this has the highest, I know that my lowest over here is francium. Okay, so highest over here, lowest over here. It's the opposite of atomic radii, right? We have the most here and the smallest here. So atomic radii and ionization energy are pretty much reversed of each other. All right, let's talk about the last trend and then we'll get to some practice. All right, our last trend that we want to talk about is electronegativity, and this is a measure of how tightly an atom holds on to its electrons, right? So based on this information, right, knowing that ionization energy is how much energy it takes to lose an electron, we can see that electronegativity and ionization energy are going to have the same trend, right? Because we know that it takes more energy, okay, to lose an electron if it's tightly held. And so if it's tightly held, it's going to have more electronegativity, right? So atoms with a smaller atomic radii hold electrons more tightly, okay? So as I move down, I'm going to decrease my electronegativity. As I move right, it's going to increase. And a couple things to note, fluorine has the highest electronegativity, okay? Then oxygen, nitrogen, and chlorine. Noble gases, so group 18, are not included in this because they are not going to form ions or bonds, right? They don't react to other things. They're super, super stable. We learned that in the last lesson, right? That they have the least reactivity. And so noble gases, unlike ionization energy, are not going to be included, all right? I can have this periodic table here. Again, there goes my lovely ding of my beautiful, awesome computer, right? So I have an electronegativity chart here, and it's color-coded. And red means it has the highest electronegativity, purple means it has the lowest, right? So I see here that most of my noble gases are not included, okay? Fluorine has my highest, okay? Then oxygen, chlorine, and nitrogen. God bless me. Sorry about that. Okay. And then my lowest is going to be that group 1, bottom of group 2, with francium being my lowest. Okay. So same trend as ionization energy. So at this point, you guys should know the drill. I want you guys to pause the video and I want you to fill out your table with this beautiful, magical, mystical information here. That should